So I'm here today at the Boston Data Festival with Professor Alan Downey, who is a professor at Olin College and also the prolific author of a number of books, including Think Bayes, Think Python, Think Stats, Think Complexity, and a few more I'm probably not thinking of.
Yep.
Alan, welcome.
Thank you very much.
So Alan, I'm detecting a theme there with all the Think books. Can you give us some insight as to what you were thinking with that series?
Right. Well, that started, the Python book was the first one. The original title was How to Think Like a Computer Scientist. And it got to be, it's a little bit too long, and I thought it wasn't really saying what the book was about. There's computer science in there, but a lot of it is really the practice of programming, software engineering, and related ideas. So I compressed it down to Think Python, which tries to convey that it's not just about the programming language, it's about a way of thinking.
Right.
And then when I started working on other topics, Think Complexity was next. That's about complexity science, stats and Bayesian stats. I wanted to get the idea across that it was really, they're about ways of thinking.
Excellent. And another subtitle you had was How to Think Like a Data Scientist. And since we're at the Boston Data Festival, would love to get some insight into that.
Right. Well, we were talking earlier, data science is such a big field. People come at it from different directions. The big pieces, software engineering is one, statistics is another, machine learning.
Of course.
And nobody knows all of these things. I think one of the things that's hard getting into the field is because there's so much. But I think a key is to find a skill set that makes sense and always be learning. You're just always picking up new skills.
Exactly, and the and you hit the nail on the head because it is a very broad field and getting broader all the time. And then, but as you've seen yourself, you're the author of Think Python and you're a data scientist. So do you think it's very necessary to have some software coding skills to be a data scientist?
I think so. It makes such a difference. If you can program in a general purpose programming language, the set of things that you can do, it just changes qualitatively. If you can't program, you're stuck with whatever the software package is. If somebody coded an algorithm for you, you can use it, but if you need something just a little bit different, you're stuck.
Exactly.
But if you bring programming skills to the table, you can clean data, you can do transformations, customize things, exploratory visualizations. There's so much more that you can do.
Exactly, and I already kind of know your bias already, but any language in particular, because there is so much out there, and especially people starting off in their career, it is kind of important to focus on one, and to hear things about R and Python. Julia is coming on now, and there's lots of languages out there that can have data science and math works. So anyone in particular you think that would be a good idea to focus on?
Right. Well, as you said, I'm partial. I'm coming from a Python background.
Yeah.
I love Python. I think the core language is great. The modules, the ecosystem is great and getting better all the time. But there's no one language to rule them all.
Right.
There's always R. I think still has a lead with the modules, the libraries.
Yeah.
Julia, as you said, is coming on. People are very excited about that. I'm looking forward to learning more about it. I know almost nothing about Julia. So
yeah, it looks actually quite exciting. They actually had a Julia conference here early in the year at MIT, and that was pretty big at 400 people. So I think that's going to start growing, be quite big in future years. And I've often told people myself, Python, R, the languages themselves. Learning those is one aspect of it, but it's kind of like a language is like a jet plane without the engines, because as you said yourself, in R it's the packages that are important, and in Python it's the libraries as well. So any particular libraries that you tend to use in your courses and your work yourself?
Right. Well, for data work, Pandas is the big one, and that's just great. I think it's one of the best designed APIs out there. Very powerful. The performance is very good. So that's my go-to for all general data work. Especially the exploratory data cleaning and visualization early on. And then stats models is another one that I use a lot. All the regression models, that's my go-to
very good.
tool.
Excellent. And being an author of a book titled Think Bayes, I know you're a big fan of Bayesian models. Can you tell us a little more about that?
I'm a big fan. I think it's a great set of ideas. When you learn about Bayesian methods, it changes the way you think about everything. So that's exciting. And then from a practical point of view, when you do Bayesian methods, the result is a posterior distribution that lets you do things that you can't do with frequentist statistics. You can take a posterior, it captures everything that you know about the problem after you've seen the data. You can use the posterior now to do whatever the next stage in the analysis is. So if you're optimizing or whatever the next step is.
Very, very good. And I have to ask, you've 4 books published at the moment. What's next in the series?
I've got 3 in the pipeline. Think Java is coming up. I'm working with a co-author on that one. Think DSP for digital signal processing. I'm excited about that because there's a nice connection, in engineering, signal processing, and in data science, time series analysis. There are a lot of interesting connections there.
Yeah.
So I'm excited about that one. And then operating systems. Think OS is the other one.
Oh wow! So you're going to have the full sweep.
I'm going to do the whole curriculum.
Excellent. Yeah, actually, that is interesting. Tell us a little more about DSP, digital signal processing.
Well, the fundamental idea, you're looking at a signal that varies in time.
Right.
You do a Fourier transform, and now you have a spectrum that tells you what the frequency composition is from that signal. And there's so many algorithms where you go back and forth between the time domain and the frequency domain.
Okay.
Some things are more visible for analysis in one domain or the other, and some algorithms are more efficient in one domain or the other.
So would I be correct in saying that there might be a lot of application for this in IoT, for example?
Absolutely. Anything if you're doing image processing or speech processing,
right?
DSP is going to be
very, very good.
Okay.
When can we expect to see that book on the shelves?
Let's see. I think that's scheduled for spring 2016.
My God, 3 books in the works. Alan, you are a machine. Alan Downey, thank you very much.